Today we're going to look at how similar triangles might apply to real life situations. And the most common place that we're going to use similar triangles and proportions and that idea is in doing indirect measurements. So this is usually used when we have something that's really tall, or the angle at which we may need to measure something out is not as easily done with the measuring tools we have available. So you may have seen along the roadside sometimes somebody looking through a little camera on a tripod, so surveyors. And one of the things that they're using is kind of similar measurements. And they're also probably going to involve trigonometry, which we're going to be studying more in Unit 7. So keep that in the back of your brain. We're first just going to look at how we could apply just similar triangles to those types of problems. So our first example. When you're outside on a sunny day, as long as it's any other time but noon, you will usually have a shadow cast on the ground from the light coming down and being blocked by you as it tries to get down to the ground. And so in this situation, a person that's 6 feet tall casts a shadow that's 1.5 feet long. And so we can think of that shadow being on the ground. We have a 6-foot person, and their shadow is 1.5 feet long. At the same time, a flagpole is casting a 7-foot shadow. And so our task is to figure out what's the height of the flagpole. And so you'll notice as I was reading through that problem, I'm actually drawing two similar triangles. I know the shadow is going to have to be in the same direction. If I imagine my sun up here, the rays are shining down and creating that shadow. And so we know the length on the base of the triangle. That's our shadow. We know the height of the person, 6 feet, but we don't know the height of the flagpole. And once we have the triangles drawn, we can just apply what we know about similar triangles and write a proportion to solve it out. And so again, the order is not as important as being consistent. So if I'm going to compare the height of the object to the shadow, then same thing, height of the person to the shadow. Then cross multiply and solve. So 1.5x is going to be 6 times 7. In other words, 42. And so x is 42 divided by 1.5, which gives us 28. So the flagpole is 28 feet tall. Alrighty, same scenario for example 2. We have a 6-foot person who's standing and they cast a shadow. However, they're standing next to a wall that's 9 feet tall, and their shadows actually end up meeting at the same place. So there's one tall shadow for the roof or for the wall, and the shadow for the person ending up in the same spot. So both are casting shadows that they end at this point down at the bottom of the triangle. If the person is standing 4 feet away from the wall, then what's the length of their shadow? And so we haven't actually figured out, the length of the wall's shadow, but do you see your similar triangles? So this is the same kind of scenario that we looked at before, where we actually want to be very careful on what proportion we set up. And so we could foreseeably do this with parallel lines. But if you don't see the parallel lines, well, let's just go with the triangles. So I have my small triangle with the 6 and the x. And then I have my big triangle with the 9 and the entire base. But if I have a 4 and an x for the whole base, what should the entire base of that triangle be? We're going to say 4 plus x. And so then we now have enough to create a proportion. So I'm going to go object to shadow equals person to shadow. Cross multiply and solve. So we have 9 times x equals 6 times 4 plus x. So distribute out your 6. So 6 times 4 gives us a 24 plus 6x. Then I'm going to subtract 6x from both sides, which gives me a 3x equals 24. So that means x needs to equal 8. So this is also a very good example of indirect measurement. You figured out how long your shadow was, and the only thing that you knew were the height of the wall and your distance to the wall, which were a little easier to measure. And that gives you enough information to indirectly find that measurement. Okay, something a little different. Let's look at hockey players. So when you play hockey, or if somebody plays hockey, it's all about the angles and passing and making sure that, you know, you can predict where the puck is going to go so you can get in the goal. So a hockey player is going to pass a puck to his teammate by bouncing it off the wall. Maybe there's somebody standing in between them and they can't go directly between the two of them. Okay, the angles formed when the puck hits the wall and bounces off are congruent. So these two angles down here are congruent. So is that enough to show that we have similar triangles? Well, yeah, don't forget we have that angle-angle rule. And as long as two angles are congruent, then we know that the triangles are similar. So we can keep going with our similar triangles rules. So we need to figure out, well, what's the distance from player one to the wall if the extra distances are shown? So if I start with an X in my proportion, I'm going to go ahead and compare it to 12. So vertical side compared to that horizontal side along the wall. And so make sure that you're going in the same order. So these triangles are pretty much just flipped horizontally from each other. So I would want to set this up as 8 compared to 9. Cross multiply and solve. So 9x is going to be whatever 8 times 12 is. 8 times 12 gives us, 8 times 12, 96. And so divide that out by 9. 96 divided by 9 gives us 10.6 repeating. 10.6 repeating. So that means player one is 10.6 repeating feet from the wall. And so notice with these application problems, I am rephrasing my answer. I'm always putting in the units of measurement, and I want to make sure that, you know, I know what it is in reference. So actually, is there anything that I should go back and do with example 2 that you can still see on the screen? What were we trying to measure on that one? The person's shadow in feet. So we should probably say the person's shadow is 8 feet. And you may not think that's super important, but if you go into science class and start thinking about amounts and measures, if you have milliliters versus liters, that is a big difference. Knowing the units that you're working with is very important. Alrighty, example 4. So another scenario, we have Katerina, who likes to sail. And unfortunately, her boat became untied from, you know, where she had it tied up, and it floated away on the lake. So she's standing up on a cliff above water level. It looks like the cliff is 25 feet tall. If she stands 10 feet back from the edge, so this is that's the 10 feet that's here, she can see the front bow of the boat. So given the extra measurements in the diagram, how far away is her boat? So it looks like Katerina is 5.5 feet taller. That's where her eye level is. And so we have one triangle up here. And then we have another triangle, the height of the cliff. Let me change my colors. The height of the cliff compared to the distance away to the boat. And so we have our two similar triangles. And so same sort of thing. We're just going to create our ratio and solve from there. So if I start with 5.5 compared to 10, what would be my second ratio? And I used height versus length. So height versus length. And again, you may set up the proportion differently, but as long as you have this on your second step when you cross multiply, 5.5x equals 10 times 25. As long as you're cross multiplying with the same things, you have a correct proportion. So then 10 times 25 gives us 250. Then divide both sides by 5.5. So 250 divided by 5.5 We get a repeating decimal, 45.45 repeating. So that means the boat is 45.45 repeating feet away from the cliff. Again, any word problems, you want to make sure that you understand your context. Now, pardon me, there's going to be a blip in the video because I need to switch over to my document camera to do the second piece. Now let's look at a more concrete example of how we could use mid-segments. So our kind of fun application, and I know my video is not all that great, it's a lower resolution, but you have your blank version that you can check out the answers on, and I will post a copy of a screenshot of what I'm doing right now. We're going to go ahead and construct the 3 mid-segments on the triangle. So what that means is on each side, I have to find the midpoint of that segment. And so what I'm going to use is the construction technique that we used a while ago is, well, let's find our midpoints. And so using your compass, and again, you could either use your straight edge compass like this or old school compass. And if you need to, you can go back and look at the possible videos, again, mathopenref.com. Look back for that in Unit 2 and Unit 3 when we did our constructions. And so to do the mid segment, I'm going to go ahead and do my bottom segment first. What I need to do, and actually let me zoom in a little bit, is I need to set my compass width to a little bit more than the halfway point on my segment. So I center it up, and then I'm going to move my compass out a little bit past the halfway point. Now, I definitely don't want to go too far out on this. I have such a large triangle that this takes up most of my piece of paper, so I don't want to take up all that room. So just past the halfway point. And then I'm going to draw an arc. And I'm going to draw this kind of lightly in pencil, and then I'll draw things in more in pen. Now, without changing the width of my compass, I'm going to go ahead and center it at the other side. So the other end point, and then draw my arc. And I didn't quite go far enough down to get my intersection point on the bottom one, so let me go back over. I haven't changed the width of my compass, so I should still be able to extend that length a little bit. And there we go. And so then I use my straight edge, and I'm going to connect those. And then to find my midpoint, really all I care about is where that's going to intersect the side of my triangle, which is right here. So I'm just going to draw in where that lines up with my straight edge. And so I'm going to do that with all 3 of them. And so I'm going to twist it around. Now, if you don't have this printed out, then just take your straight edge and draw a random size triangle. It doesn't even need to be, I got it pretty close to equilateral when I did this on the computer, but it doesn't need to be. This doesn't need to be perfect. So if you're trying this out, drawing this out on your own, definitely, maybe try it out with something that doesn't look equilateral, that's not perfect. Draw a scaling triangle if you want. It's all about the construction process. And again, the whole piece of this is I wanted to review how to find your midpoints. But second, this actually makes a pretty cool construction. So we're going to line up your top and bottom points, and then just mark where your midpoint is. And then again on the third triangle. And I'm always moving it so I've got my side kind of on the bottom. It just helps it line up. And actually looking from this angle, you can tell I don't have a perfect equilateral triangle. It is off a little bit, but that's okay. Okay, so again, center at one endpoint. Make sure my compass is a little bit past the halfway point, so it looks like it's probably there. So, and center at the other side, and do the same thing. And again, I'm keeping my pencil marks kind of light, so I know they're a little hard to see in the video, but the whole idea is being able to line things up. That's what I'm trying to do. There we go. So a mid-segment, again, that we looked at last lesson is anything that connects the midpoints. So I actually have 3 mid-segments now that I can draw. So I'm going to connect these 2 endpoints. And again, just as a review, as I'm drawing this segment, how does it relate to the segment right below it? Yeah, they should look like they're parallel. And so I'm going to turn and do the same thing. Draw my mid segment. Again, should look like it's parallel to that bottom segment. And then same thing on the other. Wait a second. What does it look like we just drew? Well, if I know these are mid segments, that means I know that these two pieces are congruent, these two pieces are congruent, and these two pieces are congruent. So actually, I drew 3 triangles that look like, you know, each side is kind of half of those sides next to it. And in fact, same thing with this middle triangle. It looks like I just made 4 similar triangles, and their sides are about half the length of the previous triangle. Now, could I keep going with it? Absolutely. So you can actually go wild and crazy on this, and let's do another set of mid segments. So I'm going to do this triangle down the bottom. I'm definitely going to set my compass a little bit smaller now because I've got a smaller triangle to work with. Again, I want to make it look like I'm just past the halfway point. I don't want great big huge arcs that I'm working with. And from the other side, technically from the mid segment. And so this is just a little bit of construction fun, but you know, this kind of relates to something that you may have seen. Has anyone ever done like those coloring books where they have something called a mandala, if I'm pronouncing that properly? And this is one of the ways that you can kind of construct those. So they start from like a triangle or circle or something like that. And it's all about dividing up the space evenly. And that's what we're doing. I'm just dividing into similar triangles that are getting smaller and smaller and smaller. And I'm doing this by doing my mid segments. But you could do this with other lengths. I'm just choosing mid segments because they're the most straightforward ones to do. It's a lot easier to find a midpoint than it is to find anything else. And center them up. And again, notice too, I am not changing my compass width when I'm drawing my arcs. So between these two drawings, I need to keep them about the same. Okay, actually, if I can keep them exactly the same, that's going to give me the most accurate graph. So now I found my mid segments on my bottom left triangle, and same thing, I'm going to go ahead and connect them. And what does it look like I've done? And hey, looky there, I've got more triangles that are actually, they're similar in the same way that the kind of medium-sized triangles are to the biggest triangle. So technically what I'm doing is I'm actually creating something called a fractal. And so what a fractal is, it's a diagram or an image where, you know, each piece is kind of self-similar to the rest of the picture. So I have the little triangle here, which is similar to the medium-sized triangle, which is similar to the big triangle. And I could keep going and dividing the space up more and more and more. And it's always going to be similar to the bigger piece or any smaller pieces. So I could keep doing this as many times as I want. And this is why you'll notice I was doing pencil marks for my arcs, but then I was drawing in my segments in pen. So what I could do, and if you're interested in doing this, you could now go through, as long as your pen is dry, go through and erase your pencil marks. And depending on how complicated you got with your drawings, you can start going through and making some neat patterns to draw these out. So after you do your practice for today, and again, you'll notice you don't have a separate lesson check. You just have a graded practice. So try that quizzes out a few times until you get, you know, a good score. That is the score that I'm going to use. It's not just a completion grade for this quizzes. And then with any extra time, again, feel free to go back, work on any test corrections for Unit 5 that you need to. But, take some time out, start drawing a cool fractal type picture like this. Or you could do your triangles, divide each one of the triangles up and start coloring it in. Have a little bit of creative time on this. But do let me know if you have any questions on our first piece, which was any of the application problems. And if not, I will talk to you or see you at our next class. All right, have a great day.